16. Radioisotopes are used to diagnose various illnesses. Iodine-131 is a radioactive isotope that has exponential decay. So it's administered to a patient, and the original dosage contains 280 MBq, and after 6 hours, we're left with 274 MBq. So what is the half-life of one iodine-131 to the nearest day? So first of all, we are given time in hours, so we convert that into days. And we need to use our exponential growth and decay formula. So it's n equals start. The base is a growth factor, and the exponent is the number of growth cycles. So there's two ways to do this. One is using a percentage growth, and the other one's using half-life. So I'm going to do it in both ways. So we'll look at setting this up just with percentage growth. So what we want to do is we have the end is 274, our start is 280, the growth percentage we don't know, and the growth cycles is 1/4 of 1 day, so 1/4 is our exponent. And then we solve for the percentage growth. So we end up with 274 over 280, and that's equal to our growth percentage to the power of 1 over 4. And then we can power both sides by 4. Okay, and that will give us our growth percentage. So when I put that into my calculator, I'm going to end up with so 274 divided by 280, and then to the power of 4. That's going to give me 0.917. Okay, so what this means is that my growth percentage is 91.7%, or I'm losing 8.3% every day. Okay, so now if I want to then find out the half-life, I set this up as I end with 1/2, I start with 1, my growth percentage is 91.7, and I'm going to solve for the number of days it takes me to get to the half-life point. And so when I do this, I'm going to log both sides. So I end up with d log 0.917. Okay, solving for d, I get log 1/2 over log 0.917, and that's approximately equal to 8 days. Okay, so using the half-life formula, the half-life formula looks like this. So for half-life, we use a base of 1/2. The start and end is the same. Now the number of growth cycles is going to be dependent on the days divided by the number of days for one half-life. So every time I hit the half-life period, I'm going to multiply by, my exponent is going to go up by 1, so I'm going to multiply by half. So that's my half-life formula. So then solving this, I get 274 over 280, and that's equal to 1/2 to the power 0.25 over t. I'm going to log both sides, so I end up with log 274 over 280 equals 0.25 over t log 1/2. Solving for t, that's the half-life period, or how long it takes to get to one half-life. So I get 0.25 log 1/2 all over log of 274 over 280, and that's again equal to about 8 days.